Welcome everyone. In this video, we are going to cover the top 10 things you absolutely must know before you start building your application with PostgreSQL. Stick around because mastering these will save you from late night debugging sessions and mysterious performance issues. Let's dive into it. The number one and most critical thing to remember is that PostgreSQL is not MySQL. They have different philosophies. PostgreSQL adheres to SQL standards much more strictly. For example, its approach to concurrency is completely different. It uses something called as MVCC, also known as multi-version concurrency control. Instead of locking rows for the reading, it creates a new version of data, which generally means better performance for application with a lot of concurrent reads and writes. Also, things like case sensitivity in text fields and the default transaction isolation levels are different. So, unlearn what you might know from MySQL and approach Postgres on its own terms. Second thing to remember is that of the data types. If you are using only integer and varchar data types, you are only using the 50% of the PostgreSQL's powers. It has incredible built-in data types that can massively simplify your application logic. You got JSONB for storing and querying structured JSON data with full indexing support, and you have arrays for storing lists directly in a column. Other than this, there is HStore for the key value pairs storage, and even native UUID and geometric types for their own requirements. Using these can eliminate the need for complex joins or separate NoSQL stores for many use cases. Third thing to keep remember is that of vacuuming while using the MVCC power of PostgreSQL. Whenever new version of row is created, the older versions become dead tuples that clutter your tables. If you don't clean them, your database will bloat and performance will tank. To solve this, the vacuum technique is integrated into the PostgreSQL. The good news is that auto vacuum is enabled by default and usually handles this for you. But you can't just ignore it. You need to monitor it and sometimes tune it for heavy write workloads. If you see your table size is growing but your data is not increasing, auto vacuum might be falling behind and you have to critically monitor it. Next comes the connection management. In PostgreSQL, every connection is a full operating system process. This makes them much more expensive than lightweight threads in other databases. Opening thousands of connections will bring your server down. Thus, you have to use the connection pooling into the PostgreSQL for the efficient management of connections and to save your servers from crashing. For the connection pooling, you can use the PG bouncer, which are inbuilt into the PostgreSQL database. They maintain a pool of active connections that your application can share, preventing connection storms and keeping your database responsive. If you don't want to use PG bouncer, you can use the application level connection pooling to address the same purpose. Next thing to remember is the index types. If you think an index is just an index, think again because PostgreSQL gives you a whole toolkit. The default B tree indexing is great, but it is not always the best choice. PostgreSQL supports multiple index types, each one of them optimized for the specific use cases. For example, you need a GIN index for the composite values such as the arrays or the JSONB document. GIST index can prove useful when you are working with geometric data or the full text search, while BRIN index can prove useful when you are working with very large tables having the sorted data, and it is incredibly efficient. Thus, picking the right index type for your application is a massive performance lever which you must think before employing the index type for your application. Next thing you must remember is the write ahead logs. In the PostgreSQL, write ahead logs plays an important role. Whenever anything needs to be written into the database files, all changes are firstly written to the write ahead logs before it is being applied to the actual data files of the database server. This is done so that whenever the database server crashes, so all of the data could be retrieved. In case the uh, some data is being written and it got crashed with the use of write ahead logs, the original data could be retrieved from there. So to manage it into your database, tune your WAL level based on your needs and configure your archive mode and archive command for the point in time recovery and understand how the checkpoint segments and checkpoint timeout affect your performances. Keeping these things in your mind will help you to optimize the database performance and for building a reliable and fault tolerant system. Next thing to keep remember is that of the PostgreSQL's extensibility because PostgreSQL can be extended with multiple plugins or say the extensions which actually boosts the PostgreSQL's functionality and performances. There comes a multiple extensions like PostGIS, PGStat statements, etc. Each of them serves the specific use cases. When you are building a geographic information systems, PostGIS extension can prove useful for you to store the spatial data into the Postgres database efficiently. And whenever you need to analyze the query performance, PGStat statements become essential in the query performance analysis. When you are building a time series data application, the time scale DB extension can prove useful and efficient for you. Therefore, always check that whether There is an extension for your application requirements before you build a complex feature yourself into the PostgreSQL directly. Next thing to remember is of the constraints and data integrity. Stop yourself enforcing all your data rules in the application code. Let the database do its job because PostgreSQL supports the various constraints and data integrity that can make your life easy. Beyond the standard primary and foreign keys, you can create a check constraints for complex validation and powerful exclude constraints to prevent things like double booking a room or overlapping time periods. This ensures data integrity at the source itself, no matter how many applications touch the database. Next thing to keep in mind is that full text search is built in into the PostgreSQL. Before you rush to set up the Elasticsearch for a simple search bar for your application, check out that PostgreSQL's built-in full text search is already available, and it is surprisingly powerful as well. It can handle stemming, ranking, and even highlighting. You create a TS vector column and index it with a GIN index and can query it with TS query. For many applications, this is more than enough and saves you the complexity of managing a separate system for the full text search capability. And last thing is to note that of the security model in the Postgres security model is granular and sophisticated. For granular level of control in the Postgres, you can use roles to group permissions and you can leverage the schemas to namespace tables and control access on them. And for the ultimate in granularity, you can use a row level security to make sure users can only see the rows they are supposed to see. Perfect for multi-tenant applications. Combine this with a properly configured pghba.conf file and hence your security will be strengthened ultimately. pghba.conf file is a crucial configuration file in PostgreSQL. It controls the client authentication and the HBA in the PG underscore HBA stands for the host-based authentication. This file defines the rules that determine whether a client connection to a PostgreSQL database is permitted or not and which authentication method should be used. This covers all the 10 crucial points to remember about the PostgreSQL. If this video helped you to understand it, hit the like button and subscribe for more deep dives into the databases and development. Now I want to hear from you that which of these points surprised you the most and how much do you like to use the PostgreSQL? Let me know in the comments below. Thank you. See you in the next part.